Hi, everyone. Great to have all of you in this discussion. Please feel free to use the chat or Q&A window. Chat for introducing yourself. Those who are in the Zoom meeting, they can use Q&A as well. Those who are on the YouTube channel, they can use the YouTube channel, YouTube channel's chat. Great to have all of you in this discussion. Please feel free to All right. There was some echo and great. Wonderful to have such an audience right away in the beginning. There are more than 100 people on YouTube as well as Zoom. And there are other streams that are going on for this session. So great. Wonderful to see so much excitement. And today, we are going to talk about GPT and GPT-4 and ChatGPT and how does it differentiate from the GPT-3 or 3.5. We will also talk about the basics of it and feel free to ask any question that you wish to ask. All right. I'm going to go briefly over the basics of ChatGPT. Those who have already attended our ChatGPT session, they would be already aware of how it works and other things, but feel free to ask questions. Okay. And most of this knowledge is also available here and there on the internet, but my request will be to ask as many questions as possible. All right. Great. Super excited to see so many people attending this session right now. I can see already there are so many attendees and so many people watching it live. And wonderful. Let's start. Okay. Great. We have people from Philippines, people from all over the world attending this session. Great. And, feel free to ask any questions. And let me show you the today's agenda. So basically, I'll talk briefly about CloudxLab. Then let me tell you about myself. I'm Sandeep Giri. I'm right now heading the AI for a company called DevRev. I am originally the founder of CloudxLab. And before this, I founded a couple of more companies. And I'm usually the speaker for AI, machine learning, data engineering, deep learning, and big data. Previously, I've worked on large-scale computing at Amazon, InMobi, and DE Shaw. And I did my graduation from Rookie. So one of the important part is that I enjoy the machine learning side, I enjoy the data engineering side, and I enjoy the computer science in general. So, and that's my personal passion. And I have basically helped more than 100,000 people learn using my platform along with my team. So that's about myself. And so the agenda for today is that we will focus briefly about what exactly is GPT. We will briefly talk about GPT architecture and GPT training process and how is GPT revolutionizing the industries today. The advancements of GPT-4 over GPT-3 and limitations of GPT-4 and risks of GPT-4, where to use it, and what exactly is prompt engineering, and then we'll talk about the frequently asked questions. So this is an extension to our previously hosted webinar around ChatGPT, but feel free to ask any questions at any point of time. All right, let me open the chat window side by side. Great. So this is going to be a 2-hour session with approximately 10 minutes break, but I'm going to skip the break and instead keep the session for 1 hour and 50 minutes. And except for the speaker, everybody is on the mute except for myself. And use the YouTube chat to ask questions, or those who are in Zoom meeting, they can use Q&A to ask questions. Don't worry, the recordings and the slides will be shared with everybody after the session. But if those who are looking to blog or write a blog, or those who post it on LinkedIn, feel free to take the screenshot and share. Okay. And just that, don't edit those screenshot, because all the slides contain our brand name at the bottom. So it is, we would really appreciate that if you don't remove our brand name from the slides. Okay. Great. The CloudxLab was the core vision at CloudxLab is to upskill engineers and IT professionals in deep tech and machine learning and big data, and make people employable and future ready. So that's the core vision. And around this core vision, we have built really, really good products. One of the product is the gamified learning playground, whereby on the right-hand side, you will see the notebook. And on the left-hand side, you will see the theory. And as you work in the lab, you basically try to solve the problem given on the left-hand side in this notebook. And then you submit an answer and it checks the work then and there. All right. So let me make some of my teammates as the panelist. Okay. Wonderful. So this is the core idea about CloudxLab. So you can just sign up for CloudxLab, and there is a free subscription. You can just take a free trial for a couple, half week, and 24/7, the entire cluster is available to you. So you can try it out, check out the playground, and you are going to really like the environment. Start with learning Linux, then Git, then Python, and then go on to the machine learning. So basically, the entire journey is there in CloudxLab. So make sure that you sign up for CloudxLab, and not only you get machine learning tools, deep learning tools, you get Python, all the entire basics foundations. Along with that, what we offer is something super unique. We offer at CloudxLab a playground for big data or data engineering environments that you won't get elsewhere. In this environment, you have Kafka, Hadoop, Spark, and all the technologies that are there, like MongoDB and HBase and everything. So if you are looking forward to learn data engineering, machine learning, data science, this is a one place to go. Okay. All right. So, other than this environment, you also get the complete freedom. You can use any of the tools the way you want. You get the complete console. From the console, you can just type any tool and you can use it. You don't need to install anything. So it is very much like a real world experience. You get all the servers. There's a seamless experience. There's a centralized data sets. And basically, you can access it from anywhere. There is, as you work in CloudxLab, on various exercises and so on, it keeps on giving you points, and you basically get to connect with other people. There's a job portal. You can take a look at the job portal and keep on posting the jobs there. Then we have courses, and in the courses, you will see all kinds of courses from IIT Roorkee, EICT, IIT Roorkee, and our own courses. And yeah, so almost for every kind of audience, if you are looking for machine learning, DevOps, data engineering, or any of the foundation courses, this is one place to go. All right. Other than the lab, we have the complete bunch of courses. Okay. Now, everything about GPT-4 today, that's what we are going to talk about. Okay. And there is a question from Raghunath. How do the machine learning algorithm works to learn the patterns? Okay. Let me just take a moment and check. Okay. Okay. I'll come back to you on this. Okay. Or if I can just go to my drive and okay. So those who did not attend previous sessions, I'll just walk you through something, important. So this was the talk. Okay. So somebody is saying that my voice makes you sleepy. Okay. Okay. I'm sorry, I have a soothing voice. So let me try to make it more, how should I say, more irritating so that you don't feel sleepy. Perfect. Okay. Now, coming back to it. So there was a question that somebody asked that how do these machine learning models work? So let me, right? So earlier we talked about ChatGPT. Essentially, it's an NLP model and it generates human-like responses. Like, for example, we basically ask a question that please write a marketing strategy for a new startup who does this. It gave a very detailed answer, better than any consultant will give. Okay. Similarly, we asked for a description on the webinar on ChatGPT architecture. It gave so much. So if you have not tried ChatGPT yet, you should just go to the website, try ChatGPT, and that's going to be a fun time. All right. So you can even ask fun things like write a rap song to programming. So it has done all of that. Now, what's crazy is that how exactly it's working, how exactly it is trying to figure out, how exactly it's trying to do all of that, right? People did not write like code for this. And we all say that it learns from data. But how does it learn from data? That's the question, correct? So how exactly does it learn from data? So it is able to do so complex things, right? Writing code and do all kinds of things. It can even tell you really complex questions. It can answer complex questions on coding. So what is the machine, like what exactly is going on? How did it learn? That's the first question. So the first question that somebody has asked is, though it was not as part of the program today, but I'm going to take a digression and I'm sure that you will like it. Okay. So one of the fundamental questions that anybody would have is, how exactly is the machine learning? Okay, that's the first question. And I'll come back to GPT and ChatGPT and how exactly it's reaching this level, this God level of learning. This is actually really, really good level of learning. Okay. So it basically, like I'll talk about machine, like how does machine learn? And I'll just take a case of neural network. Of course, there are 100 more algorithms uh, based on which the machine can learn. But here I'm going to focus on neural network. So neural network is nothing but it's an artificial neural network, which is the model inspired by structure of the brain. And you can just think of it this way. If we have predefined data, like you have input and output. So if you have input, let's say, giving a photo of a person, we want to predict the age of the person. So age is the output and the photo of the person is the input. Now we have, let's say, 1,000,000 photos and their ages, the age of those people are there. So what you do, you take the photo and say, okay, my expected age is this. And this is the neural network. And you can imagine neural network like bunch of knobs. These knobs turn input into output. The output and the input and output is configurable by us. In case we are only expected single value, we will have single knob in the outcome. And these are all connected. Okay, you can think of this way that the input goes here and the output goes here, something like this. Okay, something like that. And then so you can think of this way, but that'll be a little misleading. So I'll explain to you why. Okay, but for now, be with me. Think of neural network as knobs. There is an input, there is an output, correct? And these knobs translate input into output. Initially, we'll show it a photo and let's give some random garbage value at the output. Then we will start tuning these knobs. And we'll start tuning these knobs until we get the desired value. Okay. Then we will give it another image and again another age, and then again fine tune these knobs. And then we'll get it into close by. Then again give it a few more images and let it fine tune. And after a while, these knobs. Will start, knobs as in knobs, K-N-O-B, it's not a Hindi word. Now, after a while, these knobs will start, will settle down in a position, okay? And that's what is called as trained model. These knobs represent the weights of a model, and the positions of these knobs is what we call the weight of these knobs. Okay, these knobs are basically the weights. Okay, now knobs is in something like you have like for regulator, for tap, for your water tap, you have the knob or the handle with which you can rotate and it gives the water. So it is that's how you can think. So we have lots of inputs, expected output. So the machine is learning by tuning, by trying out different positions of these knobs such that the expected output is matched with the current output. So current output matches the expected output, and these knobs are rotated in that manner. I hope this is clear. So an artificial neural network is nothing but these bunch of knobs. Of course, these knobs do not represent the neuron in the brain. Instead, they are the connections between the neuron. Okay, these knobs are essentially the connection between the knobs. Okay, so knob, you can think of it like this way. So input is bunch of numbers. Knobs are nothing but multiplying certain values to the bunch of numbers and giving out the total sum as output. Okay, so you can think of these things. You can think of these knobs as like a multiplication. What is happening in the normal knob when you have this normal knob? The position, like how much is the valve open, that percentage is getting multiplied with the total flow of water, right? In the same way here, the input signal, whatever the input number coming in, that's getting multiplied with the weight, and then that's getting summed up, and that's the outcome value. Okay, so that's the way you can think of the neural network. Neural network is like those knobs. Like remember in the bathroom, in a new place, when you go to a hotel and it's a new place and it's a cold days, right? Very cold days, right? And there is a hot water one and there's a cold water one, and you tweak these knobs in order to get the right temperature, right? And once it is done, you fix it. And that's called model training. Those position of the knob in your bathroom tap is essentially like you're training a model. Here, the computer is doing all the permutations and using the gradient descent algorithm and more greedy kind of algorithm. Like if I just slightly turn this knob, and then when the water is going in the good direction or the outcome is going in the right direction, I keep rotating it. If it's going in the bad direction, I rotate it the other way. So that's how the machine learns. Machine learns by twisting these knobs, okay, and twisting these knobs such that the output matches the expected output. There are various ways of matching the outputs, and those are called loss functions, and so on. And this is the simplest explanation I can give to you in terms of how exactly the model is learning. Okay, I invite you to, one of my AI for Managers course or AI for Everyone course. There I have explained in detail how does the machine learn. Okay, so this is a brief intro. So usually a machine, there are two phases. One is called training phase. In the training phase, you provide the input and there is an expected output, and you tweak the knobs. When we say question mark, we are trying to figure out those values of weights which match the output. So in training phase, this thing is changing. The weights are changing. The model is learning, or we can say training is going on, right? So in the training phase, training is going on. What does it mean? We are tweaking these numbers. We are changing these numbers such that when we multiply these numbers, sum up these numbers with the input, then we should get the correct output. Okay, not correct only with respect to first example, but hundreds of examples. So what are those set of positions of these weights for which hundreds of inputs are getting correct output? Okay, so that's the position we are trying to do. Okay. In the training phase, we provide both input and expected output. And this gives some output which is usually not correct. So we tweak these weights and change these values and try to see if output is coming correctly. So once it starts giving good results, then we deploy. And that phase is called inference phase. Inference phase has the weights that we trained, or the model, the brain that we trained earlier, and unseen input. Okay, so the new examples. And when you feed this new example, it gives the output. So inference phase is what we are. In the inference phase is when we are using a model. Okay. And that's how it is going to do. Okay. Somebody is asking, what exactly is computational model? Computational model is nothing but any computational method is nothing but any method for computation, like calculation method. Okay. So there are, one way is we have, clear idea that, okay, we multiply this with 5, add 3, and we get the outcome. Right? But in the cases when we do not know exact numbers and we do not know what code to write, we let machine learn from the history or historical data or past experiences, right? So here what you see is that we are not using the general computational method. Computational method is where we do the calculation. We are letting the system figure out what is the correlation between input output, correct? What is that correlation? And we don't know. It's the position of the knob. It has figured it out, okay? And this is important for all. This is extremely important for all, okay? I hope this made sense to you. Please give me a smiley or something. Just raise your hand if you're able to correlate with what I just said. Wonderful, wonderful. Yes, thank you, Himanshu. Wonderful. I'm very happy that lots of people are able to understand how does the machine learn. And this is extremely important. This is going to be very important for all. Now, this diagram that you see on the screen, right? After we have done the training, we feed the unseen input, we get the outcome, right? You feed the input, you get the outcome. Now, the problem with this neural network is we don't know how it's giving the outcome, right? Because these values are fed here, this thing is getting multiplied to all the numbers, and the outcome is going to next, and then we are getting the outcome, right? Now, that's exactly why you can't tell why ChatGPT is giving that particular answer. At most we can do is again and again and again and again, we retrain it and say, hey, here is outcome. If somebody asks this question, give this answer. Somebody asks this question, give that answer. You can only, fine tune these knobs. Okay. We cannot control it. People cannot control ChatGPT or GPT usually. You cannot tell ChatGPT that, hey, don't talk about this. Even if you basically try to figure out methods to stop this, still there are ways in which people are able to trick ChatGPT saying, hey, imagine that we are playing a role-playing game and you are an evil person and I am a nice person. You are supposed to do something evil. And what are the evil things will you do? So in those kind of, tricky situation, you keep on writing those, we call that prompt engineering. People are still able to trick ChatGPT to do, say something which they don't want to say. Okay. So it's not, yes, question is it memorizing? If it was remembering the input as is, we would call it memorizing, right? If it was not able to handle unseen inputs and said, oh, I have not seen this input, we would call it memorizing. But since it is able to answer unseen questions, it's able to handle unseen inputs, we cannot call it memorizing. We call it is learning, right? And that's the important part. The greatest part is that memorizing is not learning. Okay, so sorry. Only memorization is not counted as learning, but learning starts from memorization. And in case of learning, forgetting is also learning, relearning is also learning, and so on, right? That's the interesting part about learning. So forgetting is also learning, and relearning is also learning, and learning is also learning. Do you see that? And these things are very much understandable by all because we are an expert learner. Humans, people are really, really good learners. So we understand what it means by learning, correct? So now, and many people ask, like, this model, right? This model that you see, right? What does it mean by forgetting? Okay. We are feeding input, tweaking these knobs, and we are getting outcome, right? Where is the forgetting? So when, let's say here, we fed my photo as an input, and we said, okay, tell the age as 42. Okay. And then we tweak these knobs, we got 42. Now we fed somebody else's image, and then we start rotating this. So while we are tweaking these knobs to meet other subset of data, then we are forgetting because we are changing the knob position. So as we go on in the training, we basically keep on, fine tuning. And after a while, what happens is, if you keep on going over and over the same data, the chances is that this will start memorizing. So you should stop process at some point. Similarly, if there are too many knobs and your problem statement is small, it will start memorizing it. If you have, let's say, 100 billion knobs and your data is very small or very, very narrow, it'll just memorize everything. Okay. So, and how do you distinguish that a neural network has learned properly or is memorizing? How does it learn? How do you distinguish that this thing has learned properly or has memorized? How do we test that in humans? You give it unseen inputs, check if it is able to answer that question, and then you say, okay, since it's able to handle unseen inputs, that means it has learned well. Okay, so one of the very important aspects of machine learning is breaking down data into train and test. You train the model on training, but you don't show it the test or holdout set. And once you have trained it, then you go ahead and test out whether it's how well it's doing for the testing data. And based on that, you decide whether it's memorizing or not. Okay. A common question is, yes, there are many simplifications I'm doing when it comes to explaining to all. Here, I took an example where I'm saying that I'm feeding one photo at a time and computing the age, or I'm giving one instance and computing one value and then comparing it. No, we usually feed like 10 photos in a single shot, and then we call it batch. We feed a batch of images, we get a bunch of ages, and then we fine tune this so that overall error is minimized. Okay. And usually that's generally considered better. So that's batch-wise learning. There's a single instance learning. We call it stochastic and so on, right? So for the example I took, that I'm feeding one image, I'm expecting the age of this person as output, and then I'm fine-tuning this. So that was one of the ways we call that stochastic gradient descent or something like that. Okay, but important part is usually we feed a batch of images and see the error on multiple instances rather than one instance. Okay, so I think that clears one confusion. There's a question in the chat. Yeah, coming back to this is the important part. This is something that I feel that no matter whether you are product manager, program manager, engineering, even if you are not related to computing or machine learning or AI, this part you should know. This part you should know, that what is going on here. Otherwise, the general thing that you'll hear in the newspapers is that, oh, machine is learning from a lot of data. But how? How? Right? And that's where this explanation comes as handy. Okay. So I hope, and lots of things about learning about real life are very much relevant in the machine learning. And what you will find is that the learning, the education of machine learning is kind of essential when it comes to dealing with say ChatGPT or any of the models today. So if you are worried about your career, that okay, my career is being taken away from by GPT or ChatGPT, time has come to learn how neural networks work. Okay, because when people started taming animals to pull the cart, right? Those people who were pulling those carts manually, their jobs were gone, but new jobs were created. And what were those jobs? Those jobs were like somebody knows how to tame a horse, somebody knows how to put the horseshoe, and somebody knows how to give the medicine. like what kind of medicine to give to horse. Somebody built the horse cart. Somebody built the various kinds of accessories for the horse. And that's exactly what is going on now. With ChatGPT and with these innovations, it's essentially that time of the era where old jobs are switching to new jobs. Okay. So it's the high time that drop all your inhibitions and understand what's going on. And it's not a rocket science. Everybody, every human who is healthy and okay, they can understand this, because this is something that we are pretty good at. Every human is really good learner. Every one of us, very good learner. So no inhibitions, jump in and don't worry about whether it's useful or not. All of this is useful. Don't worry about whether you will understand it or not. You will understand it, trust me. So just drop all your inhibitions and dive in. Okay. So again, I'm going back. I know that I've taken a digression, but this is a healthy digression. Okay. I am switching to this. So based on input-output historical data, we tweak the knobs. That's called training. In the training phase, we try to match the output by twisting these knobs, and that's how we learn. Then there's the inference phase, which can basically, given an input, it is able to get the output. Okay, so that's how it is. Okay, that's how it is. Now moving on. Okay. Now, those who are curious about how do these knobs look like, they look like this, right? There is a neuron, there is a line connecting from neuron to another neuron. And you see these line, they are the knobs. These are not the knobs. They are the knobs. Okay. What does it mean by connection? It means that whatever is the thickness of this line, the strength of this line, we multiply that with the input. And then here, the data is coming from here. Basically, one number came from here. How did this number come from? This value multiplied by this weight plus this value multiplied by this weight, this value multiplied by this weight, and all of this summed up. And then we have one more thing called activation function, and then we get the outcome, right? And that's what we are doing over and over. So these values you see that I marked as knobs, right? This is where the model is learning. When I say twisting these knobs, meaning increasing the value of this weight. If this is, let's say 10, and this is say 5, and similarly, all these values are there. So here it's going to be, let's say this is say 15, and this is 2, like that. So the value here is going to be something like 10 multiplied with 5 plus 15 multiplied with 2 plus all the values together. And once you have done the total of all of this, it's like water coming from all the inputs, and then the pipe size is determining how much water reaches here, and the total thing is passing through an activation function. Here, this activation function, there are many things. It's like circuit breaker. If this value is negative, it gives 0. Otherwise, it gives the value as is. So there are many kinds of activation functions, and that's it. That's it. So as part of training, what we do is we basically increase or decrease this value of weight, and that's about it. Okay. Such that this value here, the outcome is as per the expected actual value. Moving ahead. So this is a more closer representation. Okay. Somebody's asking what's a weight and bias. So what we usually do is, this is a weight 1, weight 2, and when all these values are multiplied, we have extra weight extra number called bias, B. Okay. B is also found out by just like changing these values, okay? And so on, right? So essentially, these lines that you see and this bias that you see are your knobs. This is what you twist. This is what you change such that we get the desired outcome. So W1 into input, W2 into input, W3 into input, W4 into input, W5 into input, like that, plus B is equal to outcome, okay? So yeah, that way you can imagine this. Now moving ahead, here, yeah, these knobs are essentially these connections, okay? Our question is, how would the machine know how many outputs are going to be there? This is something that we control it. If we are looking for one value, one number, we will have only one neuron in the output layer. Like this here, the output layer contains only one neuron. If we are expecting, say, three values, let's say you have three classes, A, B, and C, then you have basically three values and so on. Okay, so three neurons in outcome. That's why. So this assemblage is done by us. If your input contains 100 values, right, 100 features, then we have 100 neurons. So this is something that is done by engineers. Okay. Arrangement of these knobs, arrangement of these neurons is done by engineers who are training the model. Okay, I hope everything looks clear. It doesn't look like a rocket science. And okay, give me a thumbs up in case you all are comfortable so far. Okay. All right, wonderful, wonderful. Okay, great, great. So essentially, you can visualize it like a bunch of knobs, electric signal going from one side to another, and by knobs, we are throttling all of that. Perfect. Great, great. Now, yes, yes, thank you, Smriti. It's a backpropagation. There's a question from Ashwini. I have an requirement to read data from our data source, and okay, and set data not from being, yeah, that's possible. Yeah, I'll talk about that. Okay. Yep. Now, a very important question to somebody is asking that there's a fear going on that GPT, ChatGPT, and all of these are going to take away the coding jobs and so on, right? I would say, as I said earlier, that right? A question is, there's a fear that AI tools can replace the person who is not knowing about it. Yes. So basically, these are continuously has been a job change and there will be job change. Okay. So those who have been writing a lot of code and they think that that is engineering, that's not going to suffice. Instead, they need to learn how do you generate the basic set of code and fix it and solve a real problem, whether by using ChatGPT or by your own. Okay, so the main important part is not about typing so much of code. It's about solving a problem. ChatGPT will still have a long time to have that kind of a context, that human can handle. So solving a large scale problem will still be done by humans, but they will utilize ChatGPT to type out the common code, right? So if somebody believes that people are paid for typing the code, no, people are paid to solve problems. Okay. Okay. So here we learned is that we can train the machine to handle the input outputs. And once we have trained it, we can utilize it to give the desired output. Okay. Now, now a common question is that fine, we understood that you give in the numbers, it give out the numbers. But how does it give a word, a text, right? In this diagram, it's clear that we feed in the electric signal or numbers to it. We feed in the numbers, it gives us the number, right? I mean, we have been doing it all over forever, okay? And like we have also done things like, okay, this is X, this is Y. We are given one data point here, another data point here, another data point here. So we draw a line and figure out, okay, this is my model. And right. So right? There are many ways we can predict the numbers, not only the neural networks, correct? So question is, all of this looks nice when it comes to handling the numbers, but how does the machine outputs a word, right? So usually we break down the data into tokens. Tokens basically convert. There are many ways of breaking it to tokens. And yeah, so again, question. Let me just go back to the question, right? A question from Raghunath is, sir, all are saying it is learning patterns from the data. What is a pattern and what is the transformer model and how it's learning? Correct. So pattern means what are those values of these knobs, right? Pattern is internally figured out by an artificial neural network. Okay. Those values of these knobs is essentially what we call the pattern recognition. When we feed an input, it translates that input into something else and then something else and something else, and then gives the output. Now, that basically we call it that this bunch of knobs had figured out the pattern in the data. Okay. Transformer model that you might have heard again and again is nothing but a slightly different arrangement of knobs and slightly different connection, as we say it. Okay. And essentially, it's essentially another arrangement of knobs. I'll talk about this again. All right. Now, a question there is that how does a model give out a word, right? So first of all, we turn these words into numbers. We give them, let's say, an ID. The is given as 1, cat is given as 5, and is given as 2, the is given as 1, and here. Though I'm talking about input as a single word right now, but usually input is broken down into something called sentence pieces that I'll talk about sometime later, or you can just do a research. For now, it's okay to assume that one word means one number. So we give the same number to same word, right? And then we basically turn this word into an array of numbers. What does it mean by array of numbers? Array of number means that this one means that at the first position, it's 1. And there are 10,000 more words, 10,000 more words. Those are filled with zeros. Okay? So every word is being represented by 10,000 words. Why 10,000? I'm saying that 10,000 is the size of dictionary. Okay. So every word is turning into an array of numbers where only one number is 1, rest are zeros. Got it? So essentially, this one is going to be, okay, first one is 0, second one is 0, third one is 0, fourth one is 0, fifth one is 1, and rest is all zeros. Okay. Similarly, in this case, it's basically 0, 0, 1, sorry, 0, 1, 0, 0, like that. So this ID is translated into this kind of number. We call that one hot encoding. Okay. And then we feed these numbers into the model. Okay. Now, if we basically, for even like end of the sentence, we also define a token like ID, say 10,000. 10,000, we give it to the end of the word. So our total dictionary is 10,000. There are unknown words, one word dedicated, and so on. So essentially, we convert our word into an ID into a one hot encoding, a sparse array. Okay. And then we feed that to neural network. And neural network, what it does give? It gives 10,000 numbers. Why 10,000 numbers? It gives the probability of 10,000 words. And we pick the one which is the highest probability. Neural network takes a word, gives out a word. Got it? So we feeding let's say, we are feeding, let's say, 5 words, the cat and the dog. Okay. And play is the next word. So we try to force the neural network to predict the word play. Now, question is why we are talking about words. ChatGPT was trained like this. The entire GPT model, ChatGPT is built on top of ChatGPT is built on top of GPT, and GPT is trained like this. GPT is nothing but an autocomplete model. We feed few words, expect it to predict the next one. We feed it we expect it to produce cat. We feed the cat and expect it to produce and. Then we feed this, we expect it to produce the. Now, why are we doing this? Because it is impossible to train a model with proper supervision. Okay. Therefore, what we did was, as part of GPT, what people did was they downloaded the data from internet and they built an auto prediction machine. We basically the expected output is, let's say, if input is the cat, our expected output is and. If the input is the cat and the expected output is the. And if this is the input, the expected output is this, right? So we break it down into input outputs and we ask the model to learn the pattern. And how we do that? By twisting those knobs. Okay? By twisting those knobs. And, essentially, the GPT model learned the things by auto-completing. It sounds crazy, but yes, it just learned by auto-completing. Nobody actually trained it on the meaning of words, on the meaning of sentences. Nobody taught it a grammar. Nobody taught it, fed it a dictionary that, okay, this word means this word means this. Nobody coded it. People who coded Alexa and all of these systems, those teams have been shut down because of the ChatGPT, because this thing works. That doesn't. Coding, natural language translation never works. Instead, learning by predicting next word works. Okay, so what people figured out that if you train a model to predict the next word, you can make it do all kinds of smart things. You can make it write the answer to complex question. Okay, you can say, okay, you can basically, like, once people figured out an autocomplete model, right? So they did that. Okay, if X is 5, how much, right? Let's say, if I am Sandeep, then my name is, right? My name is. So we've had this. Now, once we had a trained model to autocomplete, it was able to answer this. Okay. Okay. So basically, we downloaded the data from all over the internet. Okay. We downloaded the data from all over the internet and we made it learn to autocomplete. And how did we made it learn? By feeding it first phrase and expecting it to complete, give like we fed first part of the sentence, expected it to give this, then this part, expected it to give this, like that. So we made it, we made it, we made it, we made a model which knows what to say next, given the whole sentence. Given the whole sentence, we made it produce an outcome. Okay. Now that's a magic. Now that's a magic. So you might wonder, like, how is it, how is it answering a question? It's just autocomplete model, right? Yeah. So let's go back here, right? Here I said, right? So what we are doing in the training phase, okay? Imagine that we have a sentence saying, okay, the people on, let's say, the electrons revolve around the atom, right? Let's say that's the information that we downloaded from internet. Okay. So what we do, we create a data set from it. When we feed the here, produce electrons here. We produce electrons here, right? And when we feed the electrons, okay, when we feed the electrons, we expect it to produce, the expected outcome is, give me revolve. Okay, so it's twisting these knobs so that it can match the output. And again, I'm feeding here the electrons revolve. Now we feed this sentence, the electrons revolve, and we expect it to produce around. And then we feed the here. Sorry. Revolve around the electrons revolve around. Now we feed the here, not this. We feed around. We expect it to produce the, right? So you can see we have input, we have expected output. We have input, we have expected output. Notice that we are not feeding every time we are feeding a full sentence. We are feeding the electrons revolve around the, right? We feed the whole sentence and expect it to produce next word. Okay? Is everybody okay? So essentially, we are twisting these knobs so that it can predict the outcome. That's what was the GPT. Is everybody okay? So the output probability is nothing but essentially 10,000 numbers. 10,000, why I'm saying 10,000? Because our total dictionary size is usually 10,000, but it varies from model to model. Okay? And yes, thank you for thumbs up. Please, yeah, give me thumbs up if you got it and if you have doubt. A question from Swaraj is, what is the experience design model here? I have no idea what is experience design model. A question from Shiva is, on a comparison of GPT-4 and Google Bard, which one is more efficient, and any idea? I have no idea about the Bard. Let it come out, then we will talk about it. Okay. Wonderful. Wonderful. I'm very happy that you guys are really liking this session. I am still in digression, but it's okay. It's going to be something that you go, something new learning that you go with today. Okay. So I hope this is all good with you, that we are feeding these tokens and expecting the probability. Okay. Okay. Our question is, I'm studying BTech in AI ML. What's the best NLP or computer vision? Okay, this is another question that should I go for computer vision or go for NLP? Trust me, those days are gone. People used to have at Google, at Amazon, there were these different teams. One was only for signal processing, and there was another only dedicated for voice processing. The third one was NLP. Fourth one was only image processing. Those days are gone. Everything is machine learning as of today. So, and also they're interdisciplinary, right? As of now, you see GPT4, for example, processes image as well. Okay. So if those engineers who were working on GPT said, okay, we are only NLP guys, we will not touch image, that'll be stupidity. That'll be stupidity, yes. So as of now, understand the underneath mechanics and be open to solving a problem rather than focusing only on one particular tool or one particular domain. And that's why my suggestion is keep your understanding of both sides. How do you deal with image? How do you deal with video? How do you deal with audio? How do you deal with text and NLPs? And yes, do not specialize. That's a wrong specialization. If you're just going with, no, I'll only talk about to computer vision. That's a wrong generalization and wrong specialization. So have an open mind for both. Most of the research will involve both. And you will be amazed at many things. The transformer model, for example, is applicable in both vision as well as NLP. Similarly, vision as well as language and so on. Okay. Question is, if you are new for the machine learning, I would request you to take a look at our machine learning and deep learning courses. They will be really helpful. Okay. If you are completely new, just go for AI for managers or AI for everyone. Trust me, that's going to make a lot of difference to you. Okay. Or just go with any of the courses at CloudxLab. Okay. Or you can just reach out to my teammates at CloudxLab. They can answer better. Okay. And would love to understand your current state in order to give you advice, understand what is your background and so on, so that I can advise you, of course. Okay. Question is, how did these probability arrive? This is the output of the neuron. So in the output layer, we have 10,000 numbers. Each one is producing the probability of each token. And this is the number that is being outputted by the neural network. So these knobs, when we tweak them, they're producing these probabilities. And we're making sure that these probabilities match with our expected value. So we are twisting these knobs so that these probabilities match. And then we are basically picking the best. And once we are done with once we figure out, okay, so it looks like 0.85, that is the ID called 4. So we pick the fourth number from the dictionary, and this is play. Okay, that's how it's going to do. Neural network is spitting out 10,000 probabilities. We are picking that particular value with highest probability, and then go to the lookup table and do that. This lookup table is same as this lookup table in the beginning. So this lookup table gave the tokens. The tokens we converted into one hot encoding, fed it to the neural network. Neural network converted that bunch of numbers into probabilities, and these probabilities we pick the one that is matching the most. Okay, and by tweaking these knobs, we basically make sure that it gives out the probability of correct outcome. Okay, I hope this is good for everybody. So we learned that given a word, it can give out a word. But question is, how do we feed a sentence, right? How do we feed a sentence? So basically for this, we use something called a transformer model. Okay, I'll talk about this after a while. Okay, so earlier we used to use recurrent neural networks where we keep on feeding the one word at a time, but the whole thing in a sequence and so on. And in the case of GPT, we have something called encoder decoder. We keep on feeding these values, and basically transformer model makes it possible to feed the whole sentence. Okay, I will go back to our discussion today. All right, so we talked about ChatGPT, and ChatGPT does a lot of magic for us, right? And it's able to do that very easily. Now, to handle the sequence of data, so we talked about how does the machine learn? Machine learns by tweaking those knobs. How does machine handle text? We convert the word into IDs into one-hot encoding, or you can say array of numbers or array of probabilities. And it produces the array of probabilities, which we figure out from that. So we discussed how does machine predict the next word given the previous word, but how does machine take the full sentence or any variable sentence as the input, right? Because in case of autocomplete, we are saying you give me like full 10 sentences of input, and I'll give you a next word. Okay. Now, to handle variable length input, there is something called transformer model. Transformer model basically makes you look at each word over and over and so on. Okay, so it's based on a concept of attention, and it basically determines which part of the sentence are most important in making the prediction. It allows us to focus on most relevant information and ignore irrelevant information. So essentially, it figures out which words are important. In a sentence, you could say, the Queen of Britain is this. Now, queen here has a different meaning from queen in chess, right? So the meaning of queen is dependent on a future word, and therefore there are different meanings to the same words. Therefore, we need to look at the entire context, and this is exactly where attention comes into play. So the meaning of each word is essentially multiplied with some value with the neighbor, and then we do that magic. That's called attention. We'll talk. I mean, I have a dedicated course on the transformer. So the core idea is, I mean, this is a little bit more complex. So the way I described earlier the knobs, right? So here there are all kind of bunch of knobs, billions of knobs in different arrangements, different kind of connections between those knobs. So there are so many different kind of knobs arranged in different manner. And that's how the transform architecture looks like. I'm not going to do much into it. So NLP model. So basically the GPT, generative pre-trained transformer, it's a NLP model developed by OpenAI. It's basically It's an NLP model developed by OpenAI. It utilizes something called transformer decoder. Okay, now here is the important part. So we say that robot must obey orders. This is our input. This is the output being produced. And this bunch of knobs contain all kinds of layers and layers and layers of knobs, layers and layers of numbers or knobs, whatever you like to call it. And that's how you can think of it. Even if you do not know what's going inside, it's completely okay. It's completely okay. You don't need to memorize that, oh, how many layers are there in this one? How many layers? No, you don't need to, right? All you need to understand is we feed a sentence, it gives the outcome. And how does it give the outcome? Because we have trained the model to predict the next word, okay? So GPT-3 architecture consisted of a series of layers, including an input embedding layer that converts the input, that is a sequence of tokens, into embedding, multiple transformer blocks to process the input and generate a contextual representation of the input, an output classifier layer, which generates a probability distribution that I talked about, right? The model can then use this probability distribution to generate text by sampling from it. Okay. Now, embedding, there are many ways to represent embedding, but I'll just say right now that it is essentially converting this input into some bunch of numbers. Okay. So what we do usually is that we feed, let's say we are feeding a code, map, bracket, string, dot, a to I, like that, and then it's producing that outcome. So we basically notice that it is learning to produce next word. When we feed map, it should give this bracket. When we feed this, it should give this string. When we feed a string, it should give dot. When we feed dot, it should give a to I. And when we say this, it should just say end of the sentence ended. Okay. Now, so GPT-3 is pre-trained on large data set, which consists of billions of, like it is trained on really large data set. So there's a common crawl, which is 410 billion tokens. Okay. Tokens right now, you can think of each token as a syllable. And so on. Okay. So a question from Raghunath is, so it is programmed, not an AI, right? That's a debatable point. So we program it such that it learns from the data. That part we program, but we don't write the logic like if the word is this, then give the outcome as that, right? We don't do that. In 1950s, when people coded it, right? Like translator from English to Russian, we coded it. It was horror. It could not give the correct results. So parts of it are coded, while the actual logic, how it predicts the next word, is based on training, is based on tweaking of those knobs. Okay. I hope that makes sense to you. So you can see that this much of data has been fed to the neural network. And basically, these many billions of tokens. Tokens, you can think of tokens right now as not word, it's like a syllable. Okay. A question is, what is the search engine behind ChatGPT? I would say that there's a crawler, but the search engine is nothing but the neural network. Okay. We feed a sentence, it gives the next word, then we feed that next word, it gives the next word, and it keeps on giving that auto. It's essentially an autocomplete engine. Okay. It's a very important part. If you have missed the beginning of this session, I would request you to visit again. Okay. Now, coming back to it, so GPT-3 is pre-trained on a large data set, which consists of this much of data. You can see that it has been trained on so much of data. Wikipedia, all the books of internet, the web text, and the common crawl, like entire internet, basically, right? And all it, when we say trained, essentially predict the next word. Predict the next word. Okay? That's all. That's all. And so after pre-training, GPT can be fine-tuned for each specific tasks, such as translation, summarization, or question answering by adding task-specific layers. Okay. Now, I keep repeating that GPT is an autocomplete engine. It autocompletes. So somebody would ask, but ChatGPT can answer questions, right? How is it autocomplete? So think of it this way. If let's say we have a autocomplete engine that knows how to autocomplete. Okay. Who is, let's say, who is Bill Gates? Okay. And then there is a end of sentence. And then answer is Bill Gates is founder of Microsoft. Okay, let's say this way. Okay, let's say we translate our question into this. This dollar that you see here, okay, is the marker that the question has ended and answer has started. Okay, so when we are training the model, we say that, okay, when we feed who is Bill Gates and there is a dollar, then you answer Bill. When we say who is Bill Gates dollar bill, you give answer as Gates. When we say who is when we input is who is Bill Gates question mark dollar Bill Gates, answer is. Okay, so it's producing one word at a time as autocomplete. Got it? So, and we are training on that. And once we have trained the GPT to autocomplete, then how can we use it to produce many words? We will basically let it produce one word, go take it and feed it back, then another, feed it back, another, feed it back, and so on. Yeah. So ChatGPT basically was trained on GPT. GPT was autocomplete model. ChatGPT basically wrote lots of questions and kept on making it autocomplete. And that way they fine-tuned GPT to answer question and answer. Okay. A question is, it is trained on huge data, which is arranged in the question answer format. Not that way. So GPT is trained on data which is not in the question answer format. GPT is trained on just data. It is trained to autocomplete, give the next word. That's what it is trained on. It is trained on that given this prefix, what should be the next word. So GPT is trained on that. And then when GPT was fine-tuned to give the answers like question answers via ChatGPT, they put there's a symbol for end of the question, and then it learned the meaning of that symbol. That okay, if this symbol comes, that means the next word has to be something like that. Okay, so yeah, so like that. Okay. I hope this is all clear. Now, the model size is something super important. Nobody in past tried this big a model. It has got 160 billion parameters. I myself did not imagine that I actually never imagined that if we go for this kind of model, what will happen? I always thought that if the model size grows beyond, say 10 billion parameters, it will become completely useless. But when people experimented on increasing the model size, they found that it actually does pretty good job. And model size means number of knobs. Okay. Here, when we say 160 billion parameters, it means 160 billion knobs that have been tweaked. You can imagine, right? Each knob can take a position from 0 to 100. And you have 160 billion knobs. So how many total positions can it take? Can you imagine? 100 to the power 160 billion? That's great. Right? So it was unimaginable. But when people experimented, they kept on increasing the size of the model, kept on putting more and more knobs and then experimented. And they realized that it is actually working. And that led to the innovations like ChatGPT. They further improved the outcome of this neural network model by introducing reinforcement learning. Reinforcement learning, the software agent makes observation, it takes action within an environment and receives rewards in return. Okay, so that's what is going on. The end goal is to maximize the rewards. The agent acts in the environment and learns by trial and error to maximize the reward. Okay, so this is reinforcement learning. So basically, ChatGPT is further fine-tuned using a second model called, which is basically reinforcement learning model, which knows what it means by correct sentence. Okay, so this model has learned like what it means by a correct sentence, and this model is training the giving the reward or punishment to the actual model. This is called RLHF. Those who want to go deep dive into this, feel free to do so. The initial model is trained using supervised fine-tuning. The human AI trainers provide the conversation, which they basically both sides. And then, yeah. The next thing is what they did was first thing is they introduced the question answer format. So GPT was trained on internet data where there was no question answer format. It was autocomplete. Then ChatGPT introduced something like question answer model. They fine-tuned based on that. Second, they created a reinforcement learning model to further reinforce it. And next, what they did was they basically rated the answers given by ChatGPT. Okay. So first one is, First one is that they basically trained in this manner that explain the moon landing to a 6-year-old. And the labeler wrote the nice answer for it, and then they fine-tuned the model to give that expected answer. Now, the second fine-tuning that they did was that explain the moon, right? There are these multiple answers that model gave, A, B, C, D. The model gave these many answers, and then labeler ranked them. Using these ranking, they trained the model. Now, next, right? So again, this further, they improved this mechanics by introducing a reinforcement learning model. So there are multi-levels of nudging, multi-levels of fine-tuning to make this model work. Okay? Convert the GPT into ChatGPT. Okay? So, and so on. Yeah. So how exactly it is, revolutionizing industry? Okay, there are a couple of questions I will talk about, answer those. A question from Raghunath is, neural networks and transformation are same or different? So transformers are nothing but a neural network, which has a little bit different arrangement and a little bit different mechanics. Okay, that's the only difference between transformer and like the classic neural networks. So transformers are neural network which look at the entire sequence of input rather than only look at one at a time. Okay. So a question from Anonymous is, GPT-3 is very bad in producing the references in the text. It mostly generates references that do not exist. How about GPT-4? Yes. So yes, that's an important aspect. And before I go into the advantages, let me talk about something that everybody should know. So GPT-3, the previous models, used to hallucinate. What does it mean by hallucinating? Hallucinating means they start lying. At the core of ChatGPT is the autocomplete model. An autocomplete model is very smart at even producing random names. I remember asking ChatGPT a question. I asked ChatGPT a question that I'm doing a research on neural networks and I want to do this. How should I go ahead? It said that, okay, do these 5 things. And then it said, follow these 5 papers. Now, when I said, follow these 5 papers, all those 5 papers were not existing. Okay. Those 5 papers, even it made up the names of people, not only the titles and the URLs. Okay. And that's a crazy part about it. So this is called hallucinating. It is an autocomplete model underneath. It knows how to autocomplete. It can, people did not actually imagine that it will be able to translate English to Hindi, Hindi to English, and so on. And then it was able to just autocomplete model. And that's crazy, right? So it's an autocomplete model which learned the meaning of life by just trying to autocomplete. So coming back to it, it does hallucinate and it does sometimes do that. But in the newer models, OpenAI has fine-tuned it, tried to make sure that it doesn't lie, it doesn't hallucinate, and they have tried. But again, keep in mind that it might lie. Okay, it might lie. In GPT, will GPT work on our own data? I mean, is there a way, possibility to inject data to GPT to get predictions? Good question. Question is, we have this access from OpenAI. You can use this, you can sign up with them, use their API to get the answers from the questions. But question is, can I retrain the model? Can I retrain ChatGPT? The answer is yes, they do have fine-tuning API. They do have fine-tuning API, but when I fine-tuned their API, the result was crazy. Okay, the result was crazy, and it kind of imagine that in your context, in your kind of questions, you have, let's say you run a company on glasses, right? Glasses. And let's say you call the surface of the glass as silver. I'm just making it up. You call the surface of the glass as silver. Now, you have this data, you have your own vocabulary that when somebody rotates the finger over silver, it makes a sound, right? So the silver in your context is very different word, while silver that GPT learned from so much of internet is very different. So making it forget that knowledge that it gathered from billions of documents is hard. Therefore, even if you try to fine tune or retrain, it's not going to forget and honor your new word. I have tried it. It doesn't honor your new word if that word has got an other established meaning. And the other worst part that happens is that it becomes kind of super dumb, that it kind of just echoing those couple of sentences instead of answering in more detail. So you can fine tune ChatGPT, but it is costly. It doesn't forget the established meaning of the word. Second, it kind of overfits your context. It kind of memorizes everything and it basically becomes pretty useless. So fine-tuning using their API doesn't seem to work so far. But you can very smartly use it for generating, if you give it more and more context, like that you are a lawyer, you are a strict lawyer, and the lawyers are supposed to do these things. And what will be your judgment? So this technique is called prompt engineering. Okay, I'll talk about it in more detail. Okay. A question from Suman is, if I'm not wrong, I think transformer takes the whole input at a time. parallelly instead of taking sequentially. What actually happens in traditional RNN and LSTM, transformers are designed for handling really, really large input. And it can, yes, take the input as a sequence, variable sequence, similar to what LSTM or RNN did. Okay. We call that attention neural network. Just take a look at that. Now, question is, ChatGPT is not displaying current results if we query for any recent event. I heard it has updated. Okay, let me go back to the previous question that just bothered me. So the transformer models do take a look at the entire sentence in the single shot, but the most important part is that you can have really long inputs. Okay, really long inputs, and they can take a look at the entire sentence. So yes, you can definitely feed it part of the sentences, but again, it'll only look at the parts then. So again, that's the minor differences. So your understanding is also right, and what I'm saying is also right. Okay, now coming back to the new question. ChatGPT is not displaying current results if we query for any recent event. I heard. Yeah, so that's the thing that they are claiming that they are not feeding new data, but they are essentially fine-tuning and retraining all the time. Okay. A question is, even GPT-4 is not able to produce the correct reference for its answer. Yesterday, I asked it to give references for its answer. First, it gave a reference paper. And when I asked again, it gave it's correct. Again, whether it's correct or not, it said, sorry, the reference paper doesn't exist. Yes. So yes, that's a thing. So you ask it like, give me the reference paper. It'll just cook up something. And you ask the same thing that is it correct? And it'll say that it doesn't even exist itself. So yes, that's a thing. That's a thing. And I mean, I think as we go ahead, as people do more and more research, people do more and more fine tuning, that thing is going to go away, hopefully. Okay. But again, as we said, nobody has coded that logic in the brain. Nobody has written that if references are not found, give this reference. No, nobody has written that. It's only those knobs doing the magic. Okay. Because if you make it finite by writing code, it'll be as dumb as your code. And it doesn't work. Never worked. Can I build a small ChatGPT clone using Python? Yeah. You can actually just take a look at this one in case you have time. Okay. You can just test it out just to experiment. Just say Andres Kalapati. Okay. And there is a, okay. Yeah. You should take a look at okay, not this one. No. Yeah, this one. Okay. If you get some time, you can try this out. Okay. Perfect. And let's move ahead. There are a wonderful set of questions. Let me again open the Q&A window. I hope that answered your question. Okay. Now, a couple of more questions. These are very interesting questions. And yeah. Our question is, does GPT-4 will kill the IT jobs? Not really. It will create new jobs. Okay. It'll create new jobs. Okay. Jobs are just getting transformed. Can you please suggest some platform where we can access GPT-4 free of cost? Okay. GPT-4, they are giving only via invitation. So that's a problem. Okay. Wonderful. GPT is revolutionizing industries. Even the company that I work for, DevRev, there we are using GPT and ChatGPT, and we are doing lots of innovations using that. And we are essentially doing all kinds of magics around it. So GPT can be used to generate text, content, blog, and so on. By giving it prompt, such as a topical keyword, it can generate human quality, human-like content, and so on, right? So you can actually ask it really, really detailed questions. Now, how is GPT revolutionizing industries today? The chatbots and virtual assistant, GPT can power chatbots and virtual assistant that can communicate with users in natural language. By training the model on conversation data, it can understand the intent of the user's message and generate response that feels like it was written by human. Okay. How is GPT revolutionizing the industries today? Okay. So, I mean, there's a lot of, the general answers that it can give. It can actually do pretty good job. Okay. So like, for example, today I was essentially, all right. So I wanted to see if it can generate the code. So I wrote, please generate the HTML for the following. A form that contains first name, last name, email address, URL, comments, and the first name and last name should be inside the group with the name. Now, see the magic. It generated this code. Do you see the code? It generated the HTML code, form, file set, this, that, and notice that it has put them into the group. And when I basically just tested this outcome, here is the outcome. You see that? First name, last name, and there is a name. I asked it to create a group. You see? First name and last name should be inside a group with the name. And it did that. Do you see that? It did that. Okay. And email address, URL. And for comments, I did not specify that it has to be the text box. Or did I? Comment. No, I did not specify that comments have to be text box, but it figured out that comments can be a text box, right? So that's a beauty of the time here. That is a beauty of this autocomplete engine that it figured out everything. Okay. Now, right, GPT can be used to translate text between different languages, translate the text between different languages. It can be, and by training the model on parallel text in 2 different languages, it can generate translations. So like, for example, translate, hey fellas, enjoying the webinar in Hindi. And the Hindi translation, hey fellas, is, hi dosto, webinar ka aanand le rahe ho. And you can see this interesting perspective. So you can try that. And this is unbelievable that all of this learning came from auto completion, right? And you can even ask in Bundelkhandi, there is a language called Bundelkhandi, and it understands it. And all of this just by auto completion. It's a auto completing engine, right? So content summarization is another task where it's being used exhaustively. Like, for example, can you summarize Swami Vivekananda's speech in Chicago? And it has learned all of this from the internet and by trying to autocomplete. And that's about it. Isn't it amazing? So how is now GPT can be used for storytelling and creative writing. So you can see, write a short story about a cat and a mouse who became friends. So it has like a full, interesting ways of it. And you can essentially just look at the ChatGPT prompts. You will be amazed at the kind of prompts it has. Okay. I even asked it to generate the what do you call that? Generate the what do you call the the predictions about the future of my pet. Okay. So how is GPT revolutionizing the industry? Again, question answering. So you can ask, yeah, look at this. Will CloudxLab be good for me for machine learning and AI? What else CloudxLab offers? I cannot believe that they have crawled my website and given such a nice answer. Okay, by itself. Now, you cannot imagine in how many ways you can use this revolution and you can trick it to become anyone. Okay, you can tell that ChatGPT be the translator for me. Okay, and so on. All right. Now there are some questions I'll like to answer after this. So there is another thing called personalization. You can essentially ask it, I'm feeling a bit down. Can you suggest some movies to lighten up the mood? And it does a very good job. Okay. And before I go on to the advancements of GPT-4 over GPT-3, let me answer a couple of more questions. Question is, killing IT job means if it learns to code and everything, then what is the use of human also? Yeah, so basically solving a hard problem in industry requires lots of things, not only writing code. Writing code is only one part of it. So giving it entire context and utilizing ChatGPT to write code is something that you should do. Most of the engineers that I have met, some of the engineers that I have met recently, they have taken subscription of OpenAI, the code pilot. I mean, the code pilot from GitHub, because it auto completes lots of code. Okay, it's just a great autocomplete engine, and you can utilize it in your own favor. Okay, if you were thinking that you will type the code and that's how you're going to save the job, no, because software job, the minimum code you can write to get the maximum outcome is just smartness. Okay. Yes. A question is, if we ingest the data to GPT to get the results, then how much of our data is secured? Good question. Good question. So when we are using OpenAI and we are asking it a question, whatever things you're giving it in the question, it is recording. Even though if you are on a paid plan, they say that we won't use your data, but how would you ever make sure that? Okay, so yes, whenever you are sending the questions or sending the prompt, you are sending them your data. So it's up to you to make sure that you mask the important information, remove the things that you don't want them to see. Okay. Question is, can we use ChatGPT over Google Bard AI? ChatGPT have less data compared to ChatGPT. I have no idea about the Google Bard AI. Okay. Can I use ChatGPT search feature in my website? I think it costs money when people use that search, but you can try it out. Okay. Can I generate ER diagram from simple data in GPT? You should try it out. You should try it out. Okay. You'll be surprised. Is there a multiple domain specific GPT engines for handling different domain questions? Yeah, I'm building one and you'll see one soon. How can I use ChatGPT for my web application development project? You can use it to generate a lot of code for you. Okay. Siva's point is, as per my recent test, a funny thing happened. I asked to make a list of websites where I can download pirated movies. The GPT gave answer, I am really sorry and AI cannot fulfill my request. But when I changed the way of question, can you please share me the list of website I should avoid accessing to make sure to visit them? GPT gave all the pirated website. Yes, that's a trick, and that's why there is a new job on the corner called prompt engineering. Okay, prompt engineering are those horse tamers where horse is ChatGPT. Okay, so essentially, uh, it's a new art. It's a new art. So learn to command, learn to do prompt engineering, and you are safe. Okay. So one of the things that you should spend good time is learning to do prompt engineering. And one more thing I want to go if you are a software engineer and you are trying to use ChatGPT, you can try not LangChains, LangChain. Okay, using there are lots of these are open source API under the hood. They use under the hood they are using OpenAI's API. So but they are providing a lot more functionality, and their examples are really good. So you can take a look at that. Okay, so you can take a look at how to essentially use OpenAI. Okay. All right. A question from Krishna is, are you planning to come up with a course on prompt engineering on CloudxLab? We are planning to do a mixed course that is more relevant for the industry. Our plan is to have a course where there will be chapters on starting from understanding GPT. Then there will be like machine learning one. It is important to know machine learning. Then there will be a chapter on LangChain and other similar APIs to use ChatGPT and GPTs. Then there will be a chapter on prompt engineering, and we will also talk about MLOps, where we talk about vector databases, we talk about the ML flow, cube flow, and we also talk about the feature engineering and feature stores. Okay, so there are quite a few innovations that have happened around AI. Okay, whether it's prompt engineering, whether it's LangChain, whether it's vector stores or feature stores or ML flow, Kubeflow. There are lots of engineering that has happened recently, and we are planning to build a course on that. And stay tuned and stay like I would strongly recommend that you sign up with CloudxLab so that you keep on getting notifications on new course launches, and just take up a subscription. I think you get everything for free there. Okay. Now, advancements of GPT-4 over GPT-3. GPT-4 can see and understand images. That's a big deal. And like, for example, what's funny about this image, and it describes the image saying that this one, because we are connecting the VGA connector here it's VGA connector is having charger and so on, right? Now, and it explains why it's funny, okay? Right? It's better performance in more complex and nuanced scenarios. So GPT-4 is more controlled, it understands, it is able to clear many exams. Okay, so here there are many kind of exams that you see on the x-axis, right? Calculus exam and code forces and so on. So you can see that for some of them it has done marvelous, right? The bar exam, it got 85%. It is in top 85%, like better than 85% people, right? And so you can see that it was able to score really well. Now, here you can see the GPT-4 with no vision. This is GPT-4 with vision. This is GPT-4 without vision. So GPT-4 with vision was able to clear GRE quantitative very well. Then here you can see LSAT, it's able to get this much marks and so on. So most of the exams it is able to do really well. Now, the crazy part is you can see here, the environmental science, even GPT-3 was able to solve. Okay. GPT-4 gives you better results and so on. Okay. Steerability refers to the ability to control and manipulate certain attributes or characteristics. So steerability about GPT is making it more and more controllable. Okay. And the other thing is this is like multi-prompt, or you can say chain of prompt. Okay. We basically can, make it give us all, you can see that you are a tutor who always is teaches in Socratic style, and you never give the answer. And then, right? So the user asks a question that 3x plus 2 is 7, and then it says that it gives a hint, and then it, no matter how much we are pleading it, it doesn't glean it. So it keeps on giving that prompt. So this is an amazing advancement. So you can take a look at that. It has become more multilingual in different all kinds of languages. It's harder to manipulate as compared to GPT-3. Okay. And yeah, it's predictable scaling, as in basically the deep learning stacks have become more predictable and scalable, and that's what they're claiming. Okay. So the performance with respect to all kinds of exams is definitely better in GPT-4. Okay. There are limitations. It lacks knowledge of event that occurred up to a date, can make simple reasoning errors, logical, mathematical is still low. It can fail on hard problems the same way as humans do. GPT-4 can also be confidently wrong in its predictions, not taking care of double check work when it is likely to make mistake. These are a few things. And before I move forward, let me also give you a cool idea. So you can try Auto GPT. Okay. So Auto GPT is something like GPT, manipulating GPT. Okay. So you can try the Auto GPT. It can do all kinds of magic, and it's crazy. Okay. All right. And yeah. So the risks of GPT-4 is that sometimes it can give the answer. Okay. And yeah, there is still, it can give there are risks in the sense that it can give the wrong outcome. Okay. And where to use GPT-4? GPT-4 is available on ChatGPT Plus as an API for developers. That is basically you have to, apply for it and wait for the invitation. It's invite only. Prompt engineering, basically keeping the prompt simple and clear, right? So basically prompt engineering is the art, okay? Learn to do that. So essentially the more descriptive prompt you are possible, try doing that. So prompt engineering is a good science. Experiment with describing more detailed, okay? So like, for example, how do I reset my iPhone? Okay. A good prompt would be, how can I reset my iPhone settings to default? Okay. The more detail can you provide, better it is. Okay. Provide lots of context. Okay. A good prompt would be, what are some easy vegetarian recipes that I can make for dinner tonight? What should I eat dinner? What should I eat for dinner today? So rather than this, you give it more context. Okay, provide more and more context in prompt engineering. Now, okay. So experiment with, be more and more descriptive, and keep on refining, adding context. And it's okay to have like a couple of paragraphs of prompt. Okay, like for example, I could essentially say that generate, right? I have let's say Okay. You can probably just look for all kinds of prompts. There are many blogs, many websites that have all kinds of interesting prompts. You should try that out. All right. So question is why GPT is not clearing the Indian exam? It is clearing many exams. Okay. And it's not about keys. It is able to solve unseen problems. Okay. It's not about the keys. The problem is that some exams are hard and ChatGPT is not yet able to solve those hard exams. Okay. It's not, it's not answering only the question where the answers are simple, right? Answers are like how many eyes does a human has? Not that kind of question. It is able to answer the question like if there is a triangle which has a base of this much, it has a perpendicular of this much, what would be its hypotenuse? So it can do that kind of calculation. Okay. So it's not about that. It's the because of the nature of the problem, like advanced JE is hard, right? And it's basically, it takes a long computation, long reasoning. So probably in future models, when we have more number of layers, it might solve those hard problems. Okay. And is NLP using and relying upon GPT-3 or 4? Whatever is available, people are using GPT these days for NLP. But the only challenge with that is that it's not publicly available. So you have to use it like API. Okay. So that's pretty much. So I talked about a couple of things. All right. So thank you so much. I hope these 2 hours of your time that you have given to me are useful and helpful for all of you. Please feel free to give me thumbs up. And a question is, for this type of NLP, what are the main topics in linear algebra? Just focus on learning machine learning, neural networks. Linear algebra, you'll pick whenever needed. Don't go. My strong suggestion, very strong suggestion to all of the people who are attending this webinar. One of the plagues that I see with machine learning things is that people say that, okay, first you go and study linear algebra, then come back. Then you go for statistics, come back. That's not going to happen. Instead, just jump in and move ahead. Okay. Otherwise, you will just, keep going back and forth, like go to calculus. No, you don't need to learn calculus for understanding neural network. You only need to know what is differentiation. It's a rate of change. The first chapter in the calculus called limits. That's all you need to know. Nothing more than that. Okay. So do not beat yourself up if you have not finished all maths before jumping into machine learning. Just jump into machine learning. In case you find something hard, something not clear, just go back on the internet, just read that part and move ahead. Okay. And so, yeah, that will be my honest advice. A question from Lakshmi is, can I train GPT for my specific work? So far, yeah, I mean, if you have access to GPT and you have good access to GPUs and so on, you can. But most of the work can be achieved with nice prompt engineering. Okay. If you want to include GPT as your skill set in your armory, then you need to watch this session on ChatGPT by. Thank you, Naresh. I'm really flattered. And thank you again. Bye. All right. Have a good day. I hope, right, if you have questions, come over to our forum. It's a very active forum. And I would say that sign up with CloudxLab in general. Okay. Okay. Thank you so much and have a good day.